Okay, now we are going to quickly review our exponent rules, our rules for exponents. So the first one we're going to start out with is a 3 to the 4th power times a 3 to the 3rd power. To help us figure this out, some of you guys might remember what the answer to this is, but to help us figure it out, we're going to use our knowledge that we had before. If I have a 3 to the 4th power, that means that I have 4 3's being multiplied together. Okay? If I have a 3 to the 3rd power, that means that I have 3 3's being multiplied together. So another way that I could write this 3 to the 4th power times 3 to the 3rd power would be 3 times 3 times 3 times 3 times 3 times 3 times 3, which if I count up here, there are 7 3's. So I could say that this is a 3 to the 7th power. Okay? So what do I do? So what do I do if I'm trying to figure this out? Well, I can look at their exponents here, a 4 and a 3, and those two would add together to give me 7. So this is called our product of powers rule. And the rule is that if I have an a to the m power times an a to the n power, I can rewrite that as an a to the m plus n power. Okay? So that's if they're multiplied together. If I have an x squared and an x cubed, that is simply an x to the 5th power because I add my 2 and my 3 together to give me x to the 5th. So that is my product of powers rule. Okay? Your quotient of powers rule. Okay? X to the 5th over x cubed. Some people will say, when you guys do this one, that you need to, well, let me just do it real quick. Okay? If I have an x to the 5th over an x cubed, okay, x to the 5th, that's 5 x's. Over, on the bottom, is an x cubed, so there's 3 x's. Okay? Well, what can I do with fractions if there are common factors? We can cancel them, which leaves me with 2 x's up top, so I get an x squared. So what's my relationship between my 5 and my 3 there? Well, I could take 5 minus 3 to give me the 2. Okay? So the rule for this is if I have an a to the m over an a to the m, I can take an a to the m minus n to give me my answer. Now, me personally, I do not follow this rule when I'm trying to do this. Anytime I see something like this, I just cancel them. Okay? And the reason I don't like to subtract is sometimes you'll get negative numbers and those negative numbers tend to confuse us, but those negative numbers are very important. Okay? I would much rather have something like x squared over x to the 7th and say, okay, I'm going to cancel 2 x's up top. I need to take 2 away from 7. So 2 away from 7 leaves me with 5. And now I can see that there's nothing left on top and an x to the 5th left on the bottom. Okay? The tendency is if you guys saw that, you'd say 2 minus 7 gives me negative 5. Oh, I don't want negatives. I'll take 7 minus 2. And then you end up with the 5 on top when in actuality the 5 should be on the bottom. So I always just cancel when I'm dealing with my quotient powers. Okay? Then we've got, I think, 3 more. We've got a power of powers rule. Okay? So this is, I've got 2 squared cubed. So first off, if something is cubed, that means that it's being multiplied by itself 3 times. So I'm going to have a 2 squared times a 2 squared times a 2 squared. All 3 of those are being multiplied together because this whole thing was cubed. Okay, now, individually, what is a 2 squared? Well, a 2 squared is a 2 times 2. So each of these individually is really just 2 times 2 times 2 times 2 times 2 times 2. Okay? So, oh, I thought I hit the eraser, sorry. So, really, in actuality, when I look at this, technically I'm just taking 6 2's. So this is really a 2 to the 6th power. So what's the relationship between our 2 and our 3, and how do we get to 6? Well, I can multiply those together to figure out what my exponent is. This is called a power of powers rule. So if I have an a to the m to the n power, that is going to be an a to the m times n power. Okay? So if I have an x cubed to the 7th power, that's going to be an x to the, and then I'm going to take 3 times 7. So that's an x to the 21st power if I multiply those together. Okay? The last two slides here are just expansions off of your power rule. There's a power of a product. So xy cubed. Okay? A lot of times people will want to say that this is just xy cubed. Okay? Not the case. Xy cubed means that there is an xy times an xy times an xy. So how many x's do I have up there? Well, I have 3 x's. How many y's do I have? I have 3 y's. So the important part for our power of a product rule is that 3 has to go to both of those. Okay, that 3 has to go to both of those. Okay, so ab to the n power gives me an a to the n, b to the n. Okay, now a trick that you want to pay attention for is, say I have something like an x squared y z cubed, and I'm going to take that to the 2nd power. Okay, remember your power of a power says we multiply. So 2 times 2 gives me an x to the 4th power. Okay, then I have a y there. Well, remember that's a y to the 1st power. We just don't write that. So 2 times 1 gives me a y squared. And then lastly, 2 times 3 gives me a z to the 6th. Okay, so that would be my answer there. So it has to distribute, and we're multiplying. Okay, up top, just to make sure that makes sense, that's x to the 1st, y to the 1st. So 3 times 1 gives me 3. 3 times 1 gives me 3. Okay, but it has to go to everything inside of the parentheses. Okay, and then the last one is the power of a quotient. This essentially works the exact same way. Whoops. Exact same way as the last one. Okay, there's 4 of these in there. Because it's to the 4th power. Okay, so how many x's do I have? I've got an x to the 4th. How many y's do I have? There's 2 on the bottom of each of those, so I've got a y to the 8th. Okay, so again, this n has to go to top and bottom. Gives me an a to the n over b to the n power. Okay, so that is our product of a quotient rule. Basically, on both of those two, if there's an exponent on the outside of parentheses, it has to go to literally everything inside of it. Okay. Last slide I have there is just kind of a summary page of everything. It's got your product of powers, quotient of powers, negative exponents, your zero power, power of a power, power of a product, and your power of a quotient. So everything should be there for our lesson 4.1. We will practice this next class time.